American cement makers published a blueprint for net zero by 2050 across the cement and concrete value chain. Next year, the first cement plant in the world will begin carbon capture at fully commercial scale. The Norcem plant in Brevik, Norway, will capture 400,000 metric tons of CO2 annually, which will be transported by a specially equipped ship to a CO2 storage terminal on the Norwegian coast and then piped to a geologic storage site deep under the North Sea. Here at the COP, I had the opportunity to meet President Roman Radev of Bulgaria. We discussed a project in his country to build a cement plant which will capture 800,000 tons of CO2, twice the amount of the project in Brevik, and in a region that has not yet deployed carbon capture at commercial scale. Scheduled to come online in 2028, the project has already been selected for European Union support. And at the Department of Energy in the US, we have made a grant to Heidelberg Materials to help fund a front-end engineering and design study to advance its plans to capture 95% or 2 million tons annually of the CO2 emissions from its new plant under construction in the US state of Indiana. So we are seeing project development leading to ever greater levels of carbon capture in cement production within this decade. And this push for cement decarbonization is not just limited to Europe and North America. There are significant efforts underway in India to advance carbon capture, where cement production and use is expected to rise dramatically in the future as the country continues its rapid growth and industrialization. There is also growing interest in China, which has the world's largest cement industry by far, representing a major global source of emissions. President Xi and President Biden, as many of you know, recently announced historic joint climate commitments, and members of my team at the U.S. Department of Energy's Office of Fossil Energy and Carbon Management were actually in China at the time of the announcement on a delegation meeting with our Chinese counterparts, and carbon capture on cement was a major focus of our plans for future collaboration. I would note, and you'll hear from my colleague Claude, I'm sure, that the Global Cement and Concrete Association is also heavily engaged in advancing decarbonization with the cement industry in China. This brings me to the theme of today's session, which is, can the commercialization of carbon capture, transport, and storage in cement production in developed countries support large-scale deployment in countries of the global south? The answer is yes. We know from experience, years of experience with other clean energy technologies, most notably wind and solar, that major investments in research, development, demonstration, and deployment in one country or region results in significant learning and cost reductions, which in turn drive development around the world, including in developing countries. I would note that China and India are both major global leaders in renewable energy today. And this is not to take anything away from their efforts, but it was the cost reductions achieved in other countries in early stages of those technologies that allowed China and India to vault ahead with their both manufacturing and deployment on the ground. Toward that end, the United States has enacted groundbreaking legislation that provides hundreds of billions of US dollars in funding, financing, and tax incentives that will help supercharge clean energy and industrial innovation, investment, deployment, and ultimately, and this is the most important part, cost reductions, not only in the US, but around the world, including in the cement sector. This comprehensive package includes $12 billion over 5 years, specifically for carbon management, but billions more in related industries and investments, as well as significant enhancements to our Section 45Q tax credit, which is our tax credit for carbon capture and storage. I'll just mention very briefly a few examples. We'll be investing $2.5 billion for 6 large-scale commercial capture demos, be 2 for coal-fired power generation, 2 for natural gas-fired power generation, but importantly, 2 for the industrial sector as well. We're investing $1 billion in large-scale carbon capture pilots, which the cement industry is eligible for. Importantly, $300 million over 5 years in research and development around carbon conversion, which is important in terms of using captured carbon emissions in the making and curing of concrete and replacements for cement itself. We also have a program, a $6 billion industrial decarbonization program, which carbon capture in the cement industry is eligible. The part I'm most excited about, and probably is most important actually for the cement industry, is that we have 2 provisions totaling $5 billion together for regional geologic storage and the financing of CO2 transport infrastructure. The The provisions in our infrastructure legislation for development of CO2 transport and storage are important for the cement industry because, and you'll hear about this today, the cement industry is one of the most geographically diverse and dispersed industries in the world. Almost every region that has the materials you need to make cement has production because it's a very dense, heavy commodity and challenging to transport. But what that means for carbon management and for carbon capture and storage is that the cement plants all around the world need ready access to CO2 transport and storage if they're to achieve economies of scale and bring the costs down. So we're directly supporting that kind of infrastructure deployment. We hope with this $5 billion for CO2 transport and storage will support the development of 20 to 40 regional geologic storage hubs around the United States. But again, this is not just a phenomenon in the United States. We're seeing a rapidly, I would call it almost a global movement to develop carbon hubs around the world. We're seeing them in places as diverse as, of course, North America and Europe, but the Middle East, Africa, Southeast Asia, China, and Brazil, and there are others as well. And we, as a federal government in the United States, are working actively with our partners around the world to collaborate around these hubs. Finally, I'm hopeful that the Global Carbon Management Challenge, which was launched in April by President Biden at the Major Economies Forum, will provide, we now have 18 countries, extremely diverse countries from every major region of the world, developing countries, industrialized countries, major oil and gas producers, countries that have no oil and gas, all working together. And I'm hoping that this effort will catalyze not only support for carbon management in the cement industry and other industrial sectors, but also rapidly push forward what is the next big challenge, which is how do we increase the availability of concessional finance? And I'm sure others will talk about this, but countries in the global south need access to capital at an affordable cost to build out these capture projects in the infrastructure. And that's something we'll need to continue to make progress on in the future. So going back to the original question, concluding which session, can carbon capture and storage decarbonize the cement sector and developing and emerging economies? Developed and emerging economies, the answer is yes, it can be done, and it will be done because it must be done. To achieve net zero emissions, we'll need to capture CO2 on the order of gigatons, and carbon management in the cement industry is indispensable to reaching this goal. Thank you very much.
Thank you very much, Brad, for those excellent words of welcome. So it's my pleasure to be the moderator today. My name's Tim Dixon from IEAGHG. We have a great panel of experts that we will run through. I'll introduce them shortly, and we'll take questions after each presentation, and then we'll have time for questions at the end. And at the end, Brad will come back onto the panel to take questions as well. So first of all, I'm just going to give a very brief scene-setting update. I do have to show this slide, the disclaimer slide that says, I'm not the International Energy Agency. We were set up by them, but we are autonomous from them, so anything I say does not count as their views, but I do use their material. So my organisation is actually an international research organisation in CCS, set up in 1991, funded by 36 countries and companies. And for those of you who've come to learn a little about CCS, this cartoon describes it in one picture. It's a technology that stops the emissions of CO2, the main greenhouse gas, from being emitted into the atmosphere and causing climate change. And it works on any large point source of CO2. Your power plant, refineries, gas processing. It can even capture from the atmosphere through direct air capture. It applies to heavy industry that are large point sources of CO2, such as steel, and the focus of this event today, cement industry. And we know the cement industry is important across all sectors of our economies, but it contributes about 7% of the world's CO2 emissions, more than double that of aviation. So it's really important that we tackle this. And what we do, we capture the CO2 from these large point sources and we put it deep beneath the ground, so it's not in the atmosphere. And we put it into deep saline formations or depleted hydrocarbon reservoirs. So the one thing wrong with this cartoon is the scale, because we don't just put it that deep, we actually put it at least 800 meters deep. And this is actually to scale of a real project capturing CO2 from a power plant in Canada and injecting it 3,000 metres deep. And it shows the different formations of geology that keep it trapped there. Does it stay there? Well, we have the regulations in place internationally to demonstrate and make sure it's safe and secure when it is injected. Of particular note to this UNFCCC environment, in 2011, the COP17 agreed modalities and procedures for CCS in the Clean Development Mechanism. That's for developing countries to do CCS and earn carbon credits from that. And that knowledge and experience and those agreements and principles are very relevant to the Article 6.4 negotiations and discussions going on at the moment. We also have the London Protocol that allows CO2 geological storage offshore with the requirements to protect the marine environment in doing that, including the export of CO2 for that. We have international standards. We have country-specific regulations as well in the US and in Europe as examples. And all of these draw from the IPCC's Greenhouse Gas Inventory Guidelines 2006 that has a specific chapter on CO2 injection, transport, injection and storage. And for countries who want to develop their regulations on CO2, so carbon capture and storage, my colleagues in the International Energy Agency have produced a very nice handbook on legal and regulatory frameworks that they produced last year. So why are we doing this? We see the science from the IPCC's reports. In 3 of the 4 model scenarios in their 1.5 report have quite a large amount of CCS within them. But what's most important is the one that doesn't has much higher costs. If you take CCS off the table of your mitigation options, the costs increase a lot. And this was carried through into the AR6 reports produced last year and this year, where they also summarised the total storage potential, theoretical potential on the planet as being far greater than we need to achieve limiting warming to 1.5 degrees. And they do recognise that CCS is a mature technology in some sectors. However, in cement sector, where it's a critical mitigation option, it's not as mature in its development there. And so that's why this is the theme of this event today. So my colleagues in the International Energy Agency produced their nice reports. One in 2020 summed up the role of CCUS. Specifically about this low-carbon technology, it can be retrofitted to existing energy assets, to existing power plants, to existing cement plants. That's really important in terms of when you have infrastructure already in place in a country. And they also produced, as you probably remember, in time for COP26 in Glasgow, their roadmap for the energy sector to get to net zero by 2050. And that had the headline items in there about no new fossil fuel resource developments, no new coal plant. Within that, 4 gigatons of CO2 per year by 2035 needing to be captured and stored, 7.6 gigatons by 2050. And the point that you can't achieve net zero in the energy sector without CCS. Realising that we're not making enough progress on that net zero pathway to 2050, the IEA produced their Credible Pathways to 1.5 report early this year for launching at the Major Economies Forum. This has 4 pillars for action that we need to do now to get us and keep us on the pathway by the end of this decade, 2030. And that's decarbonising electricity, reducing deforestation to zero, tackling non-CO2 emissions, and we had the methane agreement yesterday, and carbon management. That's CCS and carbon dioxide removal from the atmosphere. And the US and President Biden's administration, as Brad Crabtree just mentioned, announced the Carbon Management Challenge at the Major Economies Forum. And they've lent me a slide here to describe it. And it's really to encourage the advancement and deployment of carbon capture and storage technologies and carbon dioxide removal technologies around the world, and to do so in a collaborative way between countries as well. Collaboration is very much a theme in this technology area. And as Brad said, we've got 17 countries plus the European Commission, and it's being led not just by the US and the UK and Canada, but by Brazil and Indonesia as well. And then the rest of the countries are listed there. And we hope more will support this initiative as it goes forward. It's being launched on Tuesday this coming week here at COP28. So my colleagues in the International Energy Agency, they updated that net zero roadmap, and the bad news is we've not been building CCS projects fast enough, not as they anticipated in their scenarios from 2020. So the role of CCS is a bit reduced because we've just not been building the plants. The good news, the very good news, is the project pipeline. If you look at the top right diagram there, in the last 3 years, the project pipeline has increased remarkably. There's over 400 projects now in operation, construction, or in development. That's the good news. The bad news is, even if all those projects are completed and go into operation, that's only a third of what's required by 2030 to fit with the net zero scenario of the IEA. So we need to do more. And the reason is clearly summarised in the IEA's World Energy Outlook out last month. It's the policies are lacking. The policies are wholly insufficient to support the outcomes that match government's net zero emissions pledges. On a slightly more positive note, in the Paris Agreement as well as the NDCs, we have the requirement for countries to submit their low greenhouse gas emission development strategies. Looking to the mid-century to get to net zero, most of these have CCS in. As countries realise they're putting the easier to do mitigation in their NDCs, looking to 2030, they've got to go beyond those into the mid-century. So most include CCS. Thanks to my colleagues in the Global CCS Institute, who produce a nice global status report every year on CCS. They've lent me this map just to show you the distribution of projects around the world. There's 41 projects now in operation, 26 in construction, one of those is on cement, 325 in development, 21 of those are on cement plants. What we can say is that we do have enough projects and we have enough experience to know that the technology works. But we don't have enough projects, full stop, to meet the emission scenarios that we need. So to conclude, the IPCC AR6 says that CCS is less mature in the cement sector. And the question for the panel today is, as Brad described it, can the developments in developed countries mature the technology fast enough to assist emerging economies? And the panel we have today, we've met Brad Crabtree already. We have Professor Katherine Romanak from the University of Texas. We have Ruth Herbert, who's the CEO of CCSA, Carbon Capture and Storage Association in the UK. Beth Hardy-Valiaho from the International CCS Knowledge Centre. Jonas Helsath from Bellona. Claude Lorea from the Global Cement and Concrete Association. So with that, I will now hand over to Professor Katherine Romanak. Thank you.
Thank you, Tim. So my name is Dr. Katherine Romanak. I am a senior research scientist at the University of Texas at Austin, and I am an environmental geochemist. I've been studying CO2 storage for almost 2 decades now. So what I want to do is I want to talk about storage because I think there is rampant misinformation that is going around about storage. And so I want to tell you what the research is telling us about storage. I am a member of a Center of Excellence in CCS, which has over 20 years of research and development experience in CO2 storage, CO2 retention, and monitoring approaches. And of course, because of our knowledge in this, we want to educate the public on it. We are a large multidisciplinary team studying every single aspect of storage. And this experience has come through the U.S. Department of Energy Regional Carbon Sequestration Partnership Program, which has been, since 1997, has been put the nation into 7 different regions to systematically prove up the storage resources that we have in the United States and to develop monitoring approaches and environmental practices. With the success of that project, the U.S. is now developing large-scale storage sites, and then even past that, we heard Brad Crabtree talking about even more incentives and activity in this area by the U.S. Department of Energy. But it's not just the U.S. There's been a lot of work done in Europe as well, even though CO2 has not been injected there. CO2 does reside naturally within the subsurface, and so we can use natural analogs to study how CO2 behaves in the subsurface. We can also, because these sites do not leak, they don't leak. So how do we study what would happen if they leak? We have to make a leak happen on purpose. That's the only way we can study it. So what we do is we do shallow controlled release experiments. There's been 16 of these around the world. And as an example, I show you here one at the Zert site in Montana where pipes are put in very shallow aquifers. CO2 is bubbled into the environment. And then international scientists come from all around the world to test their tools and technologies and to assess what the environmental impacts are. So many people, understandably, have not heard of CCS, and they want information, and it's very difficult for a layman to understand CO2 storage because it's a very technical activity, and it's new. And many people have these important questions. Is it safe? Will it leak? And what happens if it leaks? And I want to tell you that those are the exact same questions that we had 20 years ago. And so what I want to do now with you in the next 4 minutes is take you on that same journey that we have been on for 20 years and show you what we have learned about the safety of CO2 storage. We've used every kind of scientific method we can to get after this problem. Controlled releases and injections into the subsurface. We use natural and industrial analogs, laboratory experiments, and numerical modeling. So how does it work? This is the fundamental misunderstanding that many people have about how CO2 storage works in the subsurface. It's actually injected through wells similar to oil and gas wells. It's injected into a reservoir with a confining system that limits CO2 rise to the surface. The salty water that resides within the formation is pushed aside, and the CO2 is trapped within the small grains of the rock, okay? So it's not in a cave or a cavern. It's in the small grains of the rock. It's stored, as Tim Dixon said, very deep, very far away from any kind of a drinking water aquifer. And it's trapped by many different mechanisms. The stratigraphic trapping of the confining system, the residual trapping within the grains, and then what happens to the CO2 over time is it dissolves, and then it mineralizes into a rock. So what we know is that the security of storage increases with time. But what are the potential unwanted outcomes that we are concerned about? Well, we don't want CO2 or salty water to migrate into the drinking water aquifer. We want to protect human health and safety, and we want to have, and we want to protect the overall ecosystem. Now, what we know is that CO2 is not toxic, it is not explosive, but it will displace oxygen in low-lying areas. So that's what we have to be cognizant of. Now, as far as brine or CO2 migration potential, what we know is the biggest risk factor are old wells, plugged and abandoned wells, okay? So we have to do our due diligence on that. Faults are possible mechanisms of migration, but we are not seeing that happening. We're not seeing that happening now, and most of these faults don't even reach the surface. So it's really about the abandoned wells being plugged, and it's about injection pressure management, which we know how to do. What's the problem with CO2 in a drinking water? If it gets in there, you just have Perrier. We drink that every day, right? That's not a problem. What we were concerned about is that the pH of the aquifer would decrease, and that minerals could dissolve, and that heavy metals could be mobilized into drinking water if CO2 ever made it into the drinking water. So what we did is we put every single scientific technique we had after this. We looked at laboratory, all those things that I mentioned before. And what we found is that if metals are mobilized, it's a small amount of metals that does not disrupt the quality of the drinking water, and it's extremely transient. These things drop back out right as fast as they dropped in. So we now have such great confidence that our drinking water aquifers will be protected at any kind of a CO2 storage site. As far as risk to human health, well, my colleagues did a really innovative study. They looked at Italy. Now, in Italy, diffuse degassing of natural CO2 happens 35 to 60 million tons per year. And what they found is that the risk was not related to how fast the CO2 was coming up. The risk was related to whether you knew it was there or not. And that is why we have monitoring procedures and regulations for monitoring at these sites. And so we monitor so that we know what's going on with the injection. They found that the risk of being poisoned at a CO2 seep was 4 orders of magnitude less than being in a car accident, being killed in a car accident. So again, the risks are looking really good for this. As far as the ecosystem impacts, what we found is you see that small little dead spot there. The impacts are spatially limited. Plants and microbes have seen this before. This is not a toxic waste. CO2 is in the soil, it's in the air, it's in the subsurface, but there's just too much of it in the air. So they know, they have actual uptake mechanisms where they can kind of deal with when CO2 gets high. But we do see that it's the plants with the well-developed root systems that are the most resilient, and that the impacts can occur at 10% soil gas CO2 at shallow depth. In a marine ecosystem, if you have a leak, what you find is little bubble plumes coming up. The CO2 dissolves into the water. It becomes dense, and it drops to the sea floor. Anything that doesn't like that scatters away. But what we do see, the impacts are going to mostly be to the small babies or the larvae of calcifying organisms. So again, however, we see pretty benign and impacts. So concluding remarks, CO2 injection is not new. We've had decades of experience. It's safe by design. We have regulations that show us how to do it. We've been using scientific approaches to make sure that it's safe for over 2 decades. And we don't see any leakage. There's some 40 projects operating around the world, and they don't leak. So we know that it's not likely even to reach the groundwater or the surface, but if it does, the impact is transient and localized. CO2 storage is effective. We've stored hundreds of millions of tons safely, and we really need to get on with it. So as Brad Crabtree said, we have the technology. We want to now transfer that to developing countries, or any country that wants to get on the path of CCS. But as we know, it takes time to develop these projects, and so just get on the path. That's what we want to do. We have the technology, we need to transfer it now. And thank you so much.
So we have time for a couple of questions of clarification, if anybody has any questions of Professor Romanak. Yes, one in the front and one behind. So two questions of clarification.
Hi, quick question. Do you have any studies done on basalts for CO2 storage?
I'm sorry, on the what?
On the basalts, the basalt finds?
Basalts.
Oh, basalts, yes. Yes, well, we have an expert in the room on that, I believe. Right now, IEAGHG's here. But yeah, there's a lot of work being done in that. And the beautiful thing about basalts is that the mineralization that happens is even faster than in a sedimentary basin. And yes, that's actively being researched and upscaled now. And as I said, there is an expert in that in the room if you want to find him. He's in the blue shirt over there.
Okay, and then there's one question there.
Thank you. Per Anke Nielsen from the Norwegian Confederation. Will there be no mineralization?
Yes, there will be mineralization, yes.
Could you...
Over time, so over time what happens is the CO2 in the formation dissolves, and then over time it mineralizes. So at first it's trapped stratigraphically, and then as the CO2 plume moves through the grains, residual trapping is left behind, and then eventually that actually dissolves and will mineralize into like a limestone type rock.
Exactly, solid.
Yes, solid.
Thank you.
Yeah.
Okay.
Just one more.
One more question then. Thank you. Last question.
Thank you, Dr. Romanak. I'm curious if you could speak more to some research that's kind of underway, including induced seismicity by CO2 and how this might differ across different geographies. We know that geographies
Sure.
of developing countries and developed countries might be significantly different.
Yeah, absolutely. So induced seismicity is another thing that we wanna make sure that we look into and we keep a handle on. And what we have found as far as seismicity is that, first of all, like some of the smaller seismic events actually give us useful information on the formation. So that's one thing. And then we're putting seismometers at these sites. We're monitoring it. We don't have any problems with it now. As we upscale it, we're going to have to definitely keep an eye on it. But, seismicity is something that has orders of magnitude, right? And so small events of seismicity, like I said, they can give us good information on the formation itself. But what we don't want is seismicity that could cause damage at the surface or reactivate faults. So what we need to do is we need to know the frac pressure of the formation, and then we need to keep our injection pressures below that. And it's something that can be managed.
Okay. Right, thank you
All
very
right,
much,
thank
Professor Romanak. So now I'm very pleased to invite Beth Hardy-Valiaho from the International CCS Knowledge Centre.
Thanks, Tim. Hi, everyone. Really happy to see a large Alberta contingent here today. Welcome to everyone. It just shows the growing interest in the area. Perfect. So I'm going to speak today about Canadian leadership on CCS on cement. So just to give you a little information about our organization, the International CCS Knowledge Centre was founded in 2017 by SaskPower and BHP, foundationally taking information from the Boundary Dam carbon capture and storage facility in Saskatchewan, Canada, the world's first large-scale carbon capture and storage facility. That one was on a coal-fired power plant looking to capture 1 million tons a year. It is safely and securely stored over 5 million tons to date. And so from that, there's a lot of learnings and information that comes from that project that helps advance CCS projects globally by sharing those lessons learned. So the Knowledge Centre is now expanding. We're doing a lot of work in Alberta with Emission Reductions Alberta to look at 11 Kickstart projects to try and take those lessons learned as well and share them globally is the intent into the future, and insert knowledge as well as outputs. There's also, we've gone around the world, talking about these projects in China, Poland, Korea, everywhere that you can think, trying to explain the intricacies that happen in getting these technologies to scale and the value and need for large-scale CCS. So I just want to take a minute to talk about cement in Canada. I know that's not exactly the topic today, but you understand why you need to reduce emissions when you understand the issue. And so together with Innovation, Science and Economic Development in Canada, the Cement Association of Canada actually launched a roadmap to net zero carbon concrete by 2050. And that roadmap commits the sector to achieving reductions of 15 million tons cumulatively by 2030. And so then having 4 million tons annually from the production of cement and concrete in Canada. It's really important to note that, Canada comparatively doesn't have big emissions, but it has a really big opportunity, especially in some of our western provinces, for sequestration. And today I'm going to talk a little bit about the Heidelberg Materials cement project that's going to be happening in Edmonton, Alberta, because I want to share with you some of those lessons learned to show how you can get these projects to come to life. So first of all, I want to talk about the timelines of a CCS project. This is an aggressive timeline to get a CCS project to happen. These projects do not happen overnight. You have to look at pre-feasibility studies and feasibility and feed studies. These are not research studies. Now, research studies are very important, don't get me wrong, but these are actual engineering detailed design studies that have, long lead contracts and other secured mechanisms that you want to have and secure over time. Not to mention how long it's going to take you to construction, commission, and have performance testing to get these projects to actual operationalization. And so in trying to get technology to move forward, it depends on organizations' risk tolerance. It depends on the extra time to mitigate risk. Do you have shutdown times? What are your labor conditions? What are your site locations? Do you have water available? Many different things all factor into if a CCS project is right for where you are. And even when it is a right fit, there are many other factors, including permitting, including regulations, including incentives and other things, collaborations, partnerships, community support, that all go into figuring out when that project will advance. I also want to talk briefly about the value of technology transfer. And before I go into speaking about Heidelberg directly, I really wanted to talk about the value of sharing lessons learned with developing countries in particular. Here we are at COP, and of course, there are many emerging economies and developed countries all here together. Taking information and being able to invest in those technologies in developed countries and taking that information and sharing it to developing countries is something that's supported underneath the Clean Tech CTCN, underneath many mechanisms for the COP, and trying to accelerate the deployment. Those investments, those large-scale investments in developed nations really can help accelerate deployment of CCS globally, which is what we want to try to achieve, to have more CCS so that we can all live in a more hospitable climate. And so when we actually insert significant practical learnings from these first mover projects, from operational experience, you can improve performance, you can reduce the costs, you can minimize the risks, and you can really ensure that those projects are going to be successful. So let me talk a little bit about Heidelberg Materials project in Edmonton, Alberta, Canada. This is going to be a first mover. It's a first full-scale application of CCS in the cement sector, the first net zero cement plant. It's a big deal. Cement, as you know, is a hard-to-abate sector, and so using CCS and cement is one of the only ways to get to net zero. And so construction on this facility is actually slated for the beginning of 2024, with the carbon capture target in 2026. So very tangible, near term. The key support to facilitate the project's success comes from different levels from both the federal and provincial governments. I'll talk a little bit about that as well. So the federal government of Canada has introduced an investment tax credit. That'll be a 50% capital investment towards projects, as well as coupled with strategic innovation funding from Innovation, Science and Economic Development Canada, as well as operational costs. So you have capital costs you have to consider, and then your operating costs. And so in terms of operating costs, carbon contracts for differences is something that's being explored right now with the Canada Growth Fund. The province of Alberta has just recently announced its carbon capture incentive program, which will be a 12% capital investment into these projects. Layering that with the federal government's 50% tax credit for projects before 2030, you are going to see these projects happening, hopefully, in a very short order. Along with that, that incentive looks to have about $35 billion of investment into the province, as well as 21,000 jobs. So I just want to highlight that Heidelberg is one of these projects that is going to move. Also, when I talk about operating costs, the TIER offset program, which is the Technology Innovation Research program that the emission money goes into. From that program, you actually have offset credits and different crediting mechanisms that ensure a price on carbon that has operating costs sustained for these projects going forward. So anybody who's looking to do a project, the Heidelberg project, tips its hat to say, this is how we get these projects to happen. So just in terms of the status of this project is currently piloting. So it's piloting this because it's never been done. It's never been done at this scale on large scale cement before. And so we are testing on site to make sure that it's going to work. We want to make sure that this project is going to work. In addition, in order to have the energy and the power that's required, we look at having combined heat and power that enhances the efficiency for the project moving forward. It takes alternative fuels from the city of Edmonton, actually, and so it's a co-benefit to make sure this project is working. It's going to capture 1 million tons a year. 1 million tons a year is a big deal. And so these are the types of projects we're happy to try and support at the International CCS Knowledge Center. We see this as a key project to be able to share lessons learned, not only with the cement sector globally, and including in emerging economies, which have a lot of cement, but also across sectors. I also want to note that there is an offtake partner in place, who's in the audience today with Enbridge, as well as different partners in a hub, Capital Power, a power plant. We're trying to bring these projects together to incent them to move. There's also a lot of community support that goes into this, consultations with Indigenous partners, a lot of people that have a vested interest in what's happening in this project. I can say firsthand that the project in Saskatchewan and Estevan, the community really bought in. People were very interested in wanting this in their economy, in their local jobs. And it has been a project that has brought a lot of life to those communities. And I think that is also something to really be concerned with for emerging and developing economies. When we take these knowledge and lessons learned, we can make those jobs and create jobs. So lastly, I just want to end here by talking about what's happening, what you can expect. 2024, we're going to continue those pilot plant operations. There's going to be continued stakeholder engagement by Heidelberg Materials. They're going to get finalized the government supports for funding in quarter one of next year. Quarter one of next year. In quarter two, we're looking for a final investment decision in June 2024, and we're going to be capturing in 2026. So with that, I'm happy to answer any questions. This is not my project. We're happy to work with Heidelberg Materials on this project, but of course there are many collaborators on this project as well. The Global Cement and Concrete Association, who you'll hear from, and many of our other partners in the room. So thank you all so much.
Thank you very much, Beth. Thank you. And do we have any questions of clarification for Beth? There's one at the back.
Hi, my name is Leanne. I'm from the National University of Singapore. Thank you so much for your presentation. I thought it was really insightful. Could I just ask, are CCUS projects being tied to carbon markets? And if so, how are those carbon credits being verified?
Wonderful, it's a great question. Actually, for this particular project, the carbon credits go through a compliance system, which is actually really fantastic. Because while there's a CCS Plus initiative happening for voluntary credits for the market to have them, be fungible, tangible, verified globally, what's really great for this project in particular is that it is a government-backed compliance market, which makes it very robust. And so definitely carbon markets have to be a part of the ongoing operations equation for carbon capture and storage facilities. Absolutely.
Okay, thank you very much. If I see no more questions, then Beth, thank you very much. Jonas, I'll get Jonas next. So Jonas Helsath, who's the director of Bellona Europe, Helsath. Jonas Helsath. Please come up and introduce us to your work in Central and Eastern Europe. Over to you, Jonas.
How's this work? Good morning, everyone, if it's still morning. Just before I start, I don't know if this no, doesn't seem to work. Oh, perfect. So just quickly, Bellona Foundation, international environmental NGO, founded in Norway back in the 80s, and now we have offices in various countries around the world. We mainly focus on Europe, which is where we are started and where we're based. I'm heading the EU work of Bellona, based in Brussels. Very much of our work is focused on industry. And why is that? Heavy industries like steel, cement, chemicals are sectors that have been, to a large extent, outside of the focus of climate action for a decade, maybe more. And the reason for that has been, to some extent, understandable. The focus has been on energy, on decarbonizing energy, where the biggest chunk of emissions still comes from. But that doesn't give us an opportunity to neglect industry. I think Brad told us earlier, if we don't decarbonize just the cement sector, concrete makes up 8% of world emissions. We cannot meet the targets. And if you add steel and cement and chemicals, the picture is very clear. This is 20%, some countries even closer to 30% of emissions. And that has been a lost decade in terms of action, what we have behind us. We need to move beyond that. And I guess the most frustrating thing about that lost decade is that we have known all along what we should have done. The technology has been available. It's not only about CCS. There are a lot of things we need to decarbonize industry, including direct electrification with renewable energy, hydrogen where that is available at scale. But CCS is part of the portfolio, and in particular for the cement sector, that's crystal clear. So why haven't we done it? For me, this is about just transition. Just transition, when it's been spoken about at the COPs, has very often been about, how do you provide a new future for coal miners that are facing job losses, facing life on the street when the mines close down. But these are industries that actually are not going to close down. These are industries that are building blocks of our future. We need cement. We need concrete to build passive housing. We need concrete to build wind turbines. We need steel for all these things. We need chemicals to isolate our houses. These are not sunset industries, as some call them. These are industries that we need to get ready for the future. And if we don't, we just get hundreds of thousands of workers on the streets protesting climate ambition, protesting climate action. There is no one who wins that conversation. Only losers. So we need to think about how we get this done, and it has to be done in a just way, not only inside Europe or inside particular countries. It has to happen in a just way across the globe, because we can't have climate action leading to massive job losses in certain places. And so the unions was actually what brought us in Bellona to work on industry as well. I guess we can say it was the other way around. We focus on industry because we knew 20 years ago we had to do that. And unions became one of the key partners. In Norway, that led to that project that Brad was referring to, which is now going to inject CO2 from the cement sector next year. It's the first cement CCS project to be in operation, and that only happened because the unions in Norway worked with us and made that case to politicians. This is about our jobs. This is about securing our future. And so, why is that relevant to other places? Norway had a lot of money. It's a big oil and gas exporter. Could use some of that money to provide the infrastructure, provide the technology, provide basically funding for the project. Is that a model that can be implemented everywhere? Certainly not. But it still has a big relevance to what we're doing elsewhere. And so the access to infrastructure is the key when it comes to carbon capture and storage. And the access to infrastructure in places like the US and in Canada is already there, because the oil and gas industry has been building pipelines for CO2 to use for enhancing oil recovery in those countries. That's not a climate action. That's been something to earn more money. But that means that they have an infrastructure in place. Most of the world doesn't have any infrastructure. And that is already a massive challenge that we have to address. That's also true in Europe. And I think, so as a European NGO, it's not often I give credit to the European Commission. I kind of hope there's no one in the Commission here because it will go to their heads. But they've actually done something which is quite revolutionary. The Commission proposed an obligation on European oil and gas producers to provide access to CO2 storage for industries around Europe based on the share of their oil and gas production in Europe. I don't think we've seen anything of the kind anywhere in the world. An obligation on the extractors, the producers of oil and gas, to provide some of the infrastructure, some of the storage capacity that industries need to decarbonize. And in fact, that has changed the entire conversation in Europe. Because until now, in the NGO community, for good reasons, a lot of people were not so keen to talk about CCS. Why? Because this was seen as something that public money is being used to benefit those that, one, created part of the problem, and two, those who really shouldn't need that public money in order to benefit from something that industry needs, i.e. the oil and gas producers, who need to be part of developing that CO2 storage and also the transport to some extent. So this has changed the conversation. Can Europe sign a letter with us recently, and they've been in the past not willing to talk about CCS. For that reason, they signed a letter saying, we need to support this. We need to support this obligation. And the reason is, they understood that you can have an endless conversation about how much CO2 storage we need. How much does the steel industry need? How much does the cement industry need? How much does the chemicals industry need? And then you can talk about circularity. How much can we do with circularity? How much can we do with hydrogen? How much can we do with electrification? These are real conversations. But if you recognize that we need some CO2 storage, it is in society's interest to provide some of the terms for how this is developing in a just way. If you leave that to the market, which doesn't exist today, there's no market because there is hardly any storage, and you leave that to companies that basically operate on 20% return on investment, plus minus, that's not a good deal for society. And it's not a good deal for our industry, and it's not a good deal for the people working in those industries that we need for the future. So we need to set the terms, and I think that brings in a societal conversation about why this is a public good and why we need to provide it. And yeah, we can talk about how much we need, but at the moment, even in the most limited scenarios for CCS, we are so far from having what we need everywhere in the world in terms of storage capacity.
Yeah,
so,
2 minutes.
I know. So I'm going to show you a couple of slides because I was going to talk about Central Eastern Europe. We have a project that's been running for a few years now. Why is this relevant? It is relevant because Central Eastern Europe is a region that has been rather absent in the conversation about CCS, also to some extent in the European climate conversation. And it is relevant in the global context because very often in Europe, this has been a pull game between the countries in the West who have more money and the countries in Central Eastern Europe who say, well, we can afford this. If you put a carbon price that is the same on everyone, we are going to go out of business. We don't have the money to provide infrastructure. But infrastructure needs to be provided in a fair way that benefits everyone. And that's why the Norway project is relevant. We didn't do that for the One Norway cement plant. We worked on that project and got the Norwegian government to invest in it because it provides infrastructure that is accessible to every industry site that is on the coast anywhere in Europe and shipping CO2 to that site. But still, we don't have a functional market. We don't have a fair access, and that's what we're working on with the European Commission. But so, Central Eastern Europe, the regulations and politics, this shows that what we really need is capacity building, awareness. In the countries there, you have some countries that are banning CO2 storage, some countries that are opening for it, and there's a lot of confusion, there's very little awareness, very little knowledge, but all of those countries have cement. All those countries have production of different chemicals. They need this. So building capacity, building understanding in those countries that this is important for them. And it's not important for the oil and gas producers in the North Sea, it is for their industries and their future, is what we're doing there. Joining up with local partners, with unions, and what we can see now, and this is so exciting, by 2030, we have planned projects in our region. These are all projects that you see on this map, are all projects that are either infrastructure projects or that are linked to cement, which is a core part of this, or they are cement plants that are planning to capture CO2. This has been developing in the course of those 3 years we've been doing this project. It doesn't mean that all of those will go ahead, but it shows that once you start having that conversation with stakeholders, with the unions, with the people who understand this is about their future, things move very quickly. So I know Tim is going to cut me off very soon. But before we do that, actually I'm going to leave this. I'm going to leave this map here. I want to talk about two more things. We need to create a race to the top. How do we create a race to the top? And how do we make sure that race to the top is benefiting everyone? The race to the top is done by creating demand for low carbon products. If we run on a model where CCS projects in cement and other sectors need to have public investment, need to have $1 billion spent by government in order to get started, that's not a model that benefits everyone. That's a model that can only be implemented in a few places. If we run a model where we talk about how to create a market for low carbon concrete, we have studies that show that the incremental price for low carbon concrete is between 1% and 5% over normal concrete. That's nothing. If you look at public procurement requirements in any country, any other requirement has a smaller impact on the cost than that. So we need to turn this around, we need to create markets, because that's how you get projects started everywhere, if they have access to infrastructure. And so that brings me to my last point, which is not on the slide, I don't know why I keep doing that. The last point is the access to infrastructure has to be a global task. Just like we say in Europe, the access to infrastructure in Europe is a European task, because we have a carbon price, everyone has a penalty. If there is no infrastructure, you don't have a functioning market anymore. So on a global level, we need to do the same. We need to raise funds to provide infrastructure everywhere where there's industry. And we actually have a proposal for that, which I'm not going to talk about now. I'm just going to tell you guys to come to our pavilion on the 9th of December at 11 o'clock, Building 88, B7. We're going to talk about a proposal that we have to use the border carbon adjustment mechanism that Europe is introducing from 2026. Use that to create a global fund that can be used to provide access to infrastructure for industries that are being targeted by that border carbon adjustment, which is supposed to protect European industry from imports that don't have a carbon legislation. And use that to provide access that can turn this race into a race to the top. So I'm looking forward to see you all there, 9th of December, 11 o'clock. Thank you so much.
Thank you very much, Jonas. And I think, thank you, Jonas. Very significant as well, the letter of support from Climate Action Network Europe for the European Commission's proposals on a storage capacity obligation. We can take one question for Jonas. Do we have one question of clarification? If not, that was very clear. Jonas, thank you very much for that. And now, do you want to go next? Okay. We'll go now to Ruth Herbert from the Carbon Capture and Storage Association in the UK to talk to us about decarbonising cement projects in the UK.
Thank you, Tim. Do I just press the green button?
Oh.
So I represent over 100 companies who are active around the world, but are mainly based in the UK. We also have around 20% of company members who are based in the EU and about 25% that are based around the world. And so we're a trade association and we cover capture, transport and storage activities, the supply chain for those, and also the service sector, which is a growing sector. So I'm just going to talk a little bit about what's happening in the UK, but also try to relate that to what might be happening in other countries as well. So that's a bit about us, which I've just said. So the UK Cluster Programme was launched really to enable the government to reach its net zero strategy. So that was published in October 21, and that set an ambition to capture and store 20 to 30 million tonnes of CO2 a year by 2030, and to establish 4 clusters around the UK to do that. Why clusters? Because that's lots of different types of assets, whether that's a power station or an industrial site or something else, all sharing the same CO2 infrastructure. So that's a cheaper way of putting this infrastructure in. The funding, however, wasn't confirmed until 2023. So that was in the budget earlier this year, and there was 20 billion a year for support for those capture projects. The clusters actually in the UK are all emerging in the industrial regions. Why? It's the same thing that Jonas was just saying. Those industries don't really see a future for themselves in a decarbonised economy without carbon capture and storage. So any industry that has process emissions that come from heating materials, so rock in the case of cement, or other types of materials in other industries, that release CO2 without CCS, even if they manage to electrify or other or their actual heat, they wouldn't be able to deal with the process emissions. And a lot of these industries need really, really hot fuels that can get things really, really hot. And so they're still looking at liquid fuels into the future. So they are looking around the UK. We looked at this last year. There's around 70 million tonnes that wanted to deploy by 2030, and that could create around 70,000 new jobs in these industries, as well as protecting 77,000 jobs in these communities. And we've got, our industrial sites around the coast. So, but we have got some inland as well that we will look at how to reach. For example, in Derbyshire, there's cement, so you'll see the peat cluster there in Derbyshire. I don't know whether you can see it on here, but it's in the middle of the country between HyNet Northwest and East Coast Cluster, and that's where all of our lime and cement is. And our lime comes from the hills there in Derbyshire. That needs to be decarbonised, and so they're looking at a pipeline across to either HyNet Northwest or Morecambe Bay stores. At the moment, we've got 2 clusters in Track 1 with 8 capture projects going through negotiations with the government for a CFD, and I'll talk more about that in a moment. And then we've got 2 other clusters, so the Scottish cluster and the Viking cluster, who are in Track 2, also starting discussions with the government about how to move forward with government support. But as you can see, we've got clusters all around the country, so there's more than 4 that need to move forward. So what is that government support? What is the 20 billion for? Well, it's for something that we call in the UK the industrial carbon capture business model, but essentially what it is a carbon contract for difference. So this is something that pays for the additional cost of operating with carbon capture minus the CO2 price, which obviously, because we have an emissions trading scheme in the UK, you would have to pay if you weren't capturing the emissions, but of course you avoid paying if you are capturing the emissions. So it just pays for the difference. So in some cases, we think that in the early 2030s onwards, that difference is actually going to be negative, as in the carbon price will rise such that the cost of doing CCS makes sense just to avoid the carbon price. But in the interim period, the government has put in place the contracts for difference. It's a very smart way of incentivising and supporting capture, because it really minimises the subsidy to just the level that's needed. And over time, as the CO2 price rises, the subsidy goes to 0. So we think it's quite smart, but we're still waiting to sign one of these contracts in the UK, and that's earmarked for next year. So, case study, one of the 8 projects I mentioned earlier in the Track 1 clusters, they're actually attached to the HyNet cluster in the northwest, is Hanson's Padeswood cement work. So Hanson is part of Heidelberg, that you might have heard of. So they are planning to capture 800,000 tonnes a year of CO2 and transport it and store it in the HyNet cluster. And as I said before, the final investment decisions for all of those 8 projects that the government's negotiating with is earmarked for around September next year, and they aim to be up and running by 2027. So as far as we're concerned, this couldn't come soon enough with the climate emergency, but it's good to have something now that everybody's focused on aiming for. That's a picture of the plant. I visited it myself this year. The people that work there are hugely excited about this, especially the younger people that work on the site with young children. They've seen themselves as part of kind of the problem. It's a dirty industry and so forth with a lot of CO2 emissions. They are so excited to have the chance to decarbonise, and it's actually making people really want to continue working at the plant and work really hard to get this project to happen. And I just wanted to say as well, we've been looking at this. Hanson's a UK arm, but it's an international company. Heidelberg have plants all over the world. So they're going to be able to go and repeat this elsewhere, and they are doing it for quicker in other places, right? So, but what this is also interesting is in this cluster there is also plans to put carbon capture on a refinery. An Indian company, SYR Energy Transition, have announced 3.6 billion only last week, basically the week just gone, to put carbon capture on their refinery and do hydrogen production, all using the same CO2 infrastructure. And the reason I met with their senior team, and the reason that they're doing this is because they see the opportunity to use the CFD and the subsidy in the UK to learn how to do that, and they're going to roll that out around the world, including back in India where they have a lot of refineries. So this is actually an international collaboration. It doesn't really matter where the first sites are or whether they're even the first sites, but people are going to go at this at their own rate, but essentially that knowledge is going to lead to deployment around the world. We looked at our own project pipeline. As I said, we did a study and found that 70 million tonnes of demand for CCS around the UK by 2030. That was last year. We updated it this year, and we found that pipeline had already grown. If you want to know, there are 90 million tonnes worth of projects around the UK. A lot of those are existing. About a third of those are new businesses that would come into the UK and set up new energy or essentially industrial businesses. For example, one energy park had a new company that was built creating green net zero building materials, and they wanted to be located in one of these clusters. So there's actually potentially greenfield new industrial sites that want to come and be near the hydrogen and CO2 infrastructure. So this isn't just a plan to retain the industry you've got. If you're a country that wants to industrialise for the first time, or in the case of the UK, maybe re-industrialise down a few avenues, then having this infrastructure really does attract business from around the world to locate in your country. And you can look at all the projects that want to have CCS through look at the QR code there and go and have a look at them. And you'll see it's a mixture of existing huge employers in regions, but also exciting new companies that are really innovating in the green transition. So in summary, there was 20 billion. We have 12 clusters. Only 4 of them are actually moving forward. We have 94 million tonnes of interest in CCS, but we have 8 projects in negotiation with the government, which is only around 10% of that. A third of the project pipeline said that they were quite mobile, so they can go to any country that's going to offer them this infrastructure. But a third of projects said they would look somewhere else or close. So some of those were brownfield sites, existing sites, if they don't have clarity in the next year or so. And the point about this is industry now is looking already at their next 5-year investment plans. So they need to know if this infrastructure is going to be there in the 2030s when they want it. Otherwise, they're going to de-invest. They're going to slowly, they're not going to, maintain those plants. They're not going to build anything new, and that's a huge risk for those communities. So what can we do about it? We're all trying to think of ideas about how we can go from 4 clusters to 12 clusters in the UK, how we can get this started in other countries. So we've done a paper with Oxford Net Zero looking at what beyond those early, the CFDs and the government support, which I think is so crucial in the next 10 years, but how do we start now putting in place frameworks that will drive wider deployment in the 2030s, because all of these industrial regions need to continue making the products that we use, products like cement that we're using for the transition. And so we've published a paper, we've got a workshop next week looking at what market developments, more robust ETS, carbon border adjustment mechanism, low carbon product standards, which Jonas mentioned, which I think are going to be incredibly important here, but also including putting those potentially on oil and gas. So what is it going to take to drive deployment of this technology more broadly? So if you're interested in this, please download the paper. I think the workshop might be full now, but we're going to carry on this dialogue and maybe do some online workshops as well. So please let us know if you're interested in that. Thank you.
So thank you very much, Ruth. And we have time for one question of clarification for Ruth. Does anybody have a question of clarification? If not, we'll move on swiftly because we'll take questions at the end as well. Thank you very much, Ruth. And now I'd like to invite Claude Lorea from the Global Cement and Concrete Association.
Thank you and good day, everyone. While the slider, you are putting the first slide in, right? Okay, I will start, and I don't want to repeat what you heard, but I cannot start without saying that concrete, yes, is an essential building material, and our forecast is that the demand for this essential product is going to grow. And I've been asked to focus on the developing world, and is actually even more important for the developing world. So the need to build, resilient infrastructure, resilient cities, green infrastructure is even going to be higher in the developing world. So this is also where we expect the demand to grow. And this was backed up by Antonio Guterres, Secretary General, to say, yes, 3/4 of the infrastructure that will exist in 2050 has yet to be built. So that's really to illustrate where we are talking about here. But as we are today, this is production of cement today is 7% of global CO2 emissions. So this is why the GCCA and its members, we developed a roadmap we committed to deliver net zero concrete to the world by 2050, and we developed a plan on how we can achieve this. And the first part of this plan is, of course, to use the levers that we know today, the low-hanging fruits that we can still push further. So it's about efficiencies in design, efficiencies in construction, using better the concrete, using the concrete more efficiently. It's all the levers that we know. It's, of course, fossil fuel substitution, energy efficiency measures, new blends, new formulation in the making of cement that are less clinker-intensive, clinker being the energy-intensive product and the CO2-intensive product. It's the greening of electricity need. It's recarbonation of cement and enhance this potential of concrete to absorb CO2 and to act as a CO2 sink. But at the end of the day, to close the loop, to get to net zero, we reckon that 1/3 of our emission reduction are going to come for carbon capture, use and storage. So it's important. And if we want to look this into the bigger picture without duplicating what Tim presented, but that's the MPP sectoral transition strategy, and it estimates the need for CCUS to decarbonize 7 sectors to top to 4 gigatons per year. We reckon in our roadmap we will need 1.3 gigatons. So it's huge what we have to develop. And it's a huge challenge, and we are working on it, and we will see it. We see more projects, of course, in the developed world, but we're also working in preparing for this transition in the developing world. So the technologies, they exist. So we heard this today, the technologies are there. Some are still at a rather low TRL level, and we are actually doing all the work we do to also move up, and have the technologies at higher TRL that will also help, of course, to optimize, to make the technologies more efficient, but also to drive the cost of the technologies down, because it's still expensive as we see it. And this is now one of the key challenges today, is as long as we don't have the business case for CCUS, without support from governments, without grants, without the type of scheme we have seen in the UK, we can't build those projects. So we need to have the business case for CCUS. So the business case to support the technical risk, to support the regulatory risk, the financial risk. So there are still many risks there that we have to cover. And then, of course, we also have all the operating risk to cover. So we need a carbon price. This is essential. We need a carbon price, and we need low procurement policies to help to make the business case. But we also need many other things. We need infrastructure for transport and storage. We need renewable energy. A carbon capture plant in cement will at least double the need for electricity. So that electricity needs to be renewable. So there are a lot of parameters that need to come to build a business case. This is a map of a current project. This is a collaboration between the GCCA and Lead It. And this is all the carbon capture project that you have in the cement industry. This is called the Green Cement Technology Tracker. You can download there detailed data about all the plans. And actually what I want to show here, you can look at this in detail and look at all projects, but what I want to highlight here is that you see a big concentration of projects in Europe and in the US. So this is clearly what we see. There are some projects elsewhere in the world we heard about, and they are not all yet on the plan, but there are now, as far as I know, 4 projects in China for CCUS in cement. But yes, most of the projects are in Europe. And of course, it's because there are significant investment there and support schemes for the project. We have the EU Innovation Fund, you have the US Reduction Act, and all the policies that were introduced by Brad earlier. And actually, in other geographies in the developing world, we are really facing a lack of support, but also a lack of carbon pricing. I mean, the enabling framework is not there to make the case for CCUS. And this is where we are with the GCCA. We have a collaboration with the Clean Energy Ministerial. We are collaborating with governments, but we are also collaborating with our members. So I showed our roadmap, our global roadmap, but we also have a net zero delivery program, project accelerator, where we are working together with the countries and the regions to develop national roadmaps or regional roadmaps, but also working on what are the policy needs in that region, what are the enabling policies that need to be developed, and working on lighthouse project. So that's the map. You see the countries where there is a roadmap, the countries where we have initiated discussions about the roadmap, or where roadmap are in progress. And there, and this is really what I want to focus now, is we have worked out kind of typical national project contact for CCUS in a country. Because whilst we are waiting to get the right enabling framework and working in getting the right enabling framework, there is already quite some work that can be done, because we need to be ready to deploy that technology by 2030. And so this is a project that now we have initiated in India with the Global CCS Institute. I think it's a great collaboration where we are looking at mapping the sources, the cement plants in India, and also mapping the hubs and the storage options. We will, of course, then work on the enabling policy framework with the Indian governments and GCCA India. We have the backup of the GCCA India CEOs for this project, so members are now submitting where they think we could have lighthouse project, and the idea is really to find 2-3 lighthouse projects in India. And we're already talking about what could be the next country to develop this program. I think we have seen a very interesting project as was in Nigeria, which served as a model to build this project. And this is really what we are doing to help the developing world also benefit from the learning. And as an addition, as the GCCA, we have recently as well developed a handbook for our members together with the CCS, International CCS Knowledge Center, actually, to also help our members. Okay, if I want to do a CCUS project, what do I need to look at? What are the questions? Because it's not only about the technologies, it's around a lot of other topics. So to sum up, because I think I'm getting close to my 10 minutes, so the technology works, but we need to finance and de-risk the technology. We need to be ready to deploy. The 1.3 gigaton is 1 plant per week as from 2030, that we will need to equip. I like to repeat that number to give us an idea of the scale of the job here ahead of us. We need to develop the infrastructure, and this is where governments are key, or stakeholders, national stakeholders, develop the infrastructure for the transport and the storage, the mapping, and then ensure the supporting policies to help us to make the business case for CCUS. Thank you very much, and I'm here for questions.
Thank you very much, Claude. Thank you. Do we have any questions of clarification for Claude before we move to more general Q&A? If we don't, Claude, thank you very much. If you'd like to take your seat, and can I invite Brad Crabtree to join the panel for the Q&A at the end? Thanks, and we'll just open it up for general questions now on anything to do with CCS on cement or anything on CCS in general. And I thought that was very useful already, thinking about the question that we've got: can developments in CCS on the cement industry in developed countries move fast enough to help developing countries? And before we've even got the first plant operating next year, the Global Cement and Concrete Association are helping India move along and considering CCS for there. So that's very good to learn of that, Claude. Thank you. So do we have any questions for the panel at all? Yes, we've got one over there, please.
Hi, yeah, so...
Oh, can you wait for the microphone, because we've got people online as well. Thank you. If you could say your name and affiliation as well, would be helpful. Thank you.
My name is Jacob Dalmer. I'm a junior at Moravian University in Bethlehem, Pennsylvania. You mentioned, this is for Dr. Romanak, you mentioned that over time the carbon that's stored turns into limestone, or it crystallizes, right? Yeah, right. So I was wondering how long would it take to, like, once all the carbon crystallizes, does that mean that that storage facility is full? And if so, how long do you think carbon storage is a viable option for
So it's not the mineralization that will necessarily limit the storage capacity. It's more of a pressure of the initial, it's more a function of the initial pressure and porosity, permeability, all of those things in the formation. So really it will be limited before it will be crystallized. So the crystallization will not be the limiting factor.
Yeah, so just to add on, do you think that this will be, carbon storage will be an option for my great-grandkids, tenfold over?
Well, that's a really good question, and the assessments that we have right now are that we have orders of magnitude more storage than we need. So, that's going to all bear out, because we also need storage to be in a certain location. But, basically now we've got orders of magnitude more storage than we need.
Thank you.
Yeah, thank you.
Okay. We have a question in the middle of the... Alina, thank you.
Thank you very much. My name is Elena Levin. I'm from the Global CCS Institute. And first of all, I just wanted to congratulate Tim and Katherine and all the panelists for putting together this session to talk about CCS as a matter of fact, as guided by reality, economics, and science, and away from ideology, because I know some people are still shy to talk about CCS. So it's great that we're having this conversation today in the UNFCCC context, and I hope there'll be more of those conversations. I have two questions about emerging economies. And I think, we're here in Dubai, we see all the constructions going on, and that's probably the side of the future in many emerging economies. So one question, maybe more for Brad and other governments, in terms of geological storage assessment, are there any collaborations, or can we envisage a global collaboration on storage potential estimation and assessments, so that infrastructure that every speaker mentions, that is there when the industry is ready to start capturing and storing CO2. So one question on that, and another one is on funds. We have Global Climate Fund that hasn't funded any of the CCS projects yet. So what does it take for the Global Climate Fund to start funding CCS on cement? Because as we heard, CCS is one of the critical components of decarbonizing cement sector. Given the construction that will be happening in developing emerging economies, all of them will need CCS on their cement and concrete plants. So how can we leverage or direct investments in CCS plants in emerging economies? Because we know in developed countries, Brad mentioned about US support, we heard from Ruth about support in the UK, so that how to get that support in developing countries through the funds.
Okay, Elena, thank you very much. Now, just to make everyone aware, I think the mics get cut on the hour promptly, so the speakers will take questions outside afterwards as well. I can see the lights flashing with 1 minute, so if Brad and then Katherine can answer those 2 questions, but the panellists will be available afterwards outside the room to continue answering questions if we don't get to you. So okay. Brad first.
So 2 quick responses. On resource characterization, that is an area that we are working bilaterally with a number of countries to support their efforts on characterizing geologic storage potential. There needs to be more resources devoted globally to that. It's probably one of the it's fundamental to projects moving forward. It's also probably the least cost, most impactful way governments in wealthy countries can contribute to deployment in the global south. There are other enabling things that relate to that. Regulatory geologic storage frameworks, the regulation that's necessary for projects to have financial certainty. We're working with a number of countries in the global south to help them develop regulatory frameworks for geologic storage. I would identify both those things as priorities that fit together. And then the second question, as far as the funds, there's actually multiple funds. There's the one you mentioned. And then there's also the fact that the World Bank CCUS fund is ending, and we want to make sure that there's a fund that continues after that, a new fund. One, we need countries like the United States, through their directors at the World Bank and other multilateral institutions, need to start getting coordinated and applying pressure. This will also be an area of focus for the Carbon Management Challenge, so that we could be over 20 countries here in a few months. And one of the things that we'll be starting to do next year is coordinating efforts and joint priorities to engage together. That's part of the whole point of that effort, to have a global voice.
Katherine, do you want to just say something on the Green Climate Funds?
Well, I mean, we've been working for years to try to mobilize funds from the Green Climate Fund, and I think we're real close. So it's looking good, I think, maybe for a start. But hopefully, if we can open it up, then we'll get more countries being funded. Okay,
and the mics have not been cut yet, so can we take your question?
So Adam Sweet from Edmonton, Canada. 2 quick questions. One, because this requires knowledge sharing amongst companies who are largely competitors, can the panel speak to how do you get those competitors to work together? And the second piece around shared liability, where you have the producer of the CO2, the person who's maybe getting it to the the person who's or the company that's putting it under. How do you, particularly maybe in the UK context, how is that being addressed in terms of the shared liability in the case of something going sideways?
Hello, excuse me. Unfortunately, we need to prepare the room for the next event.
Perfectly understandable.
Kindly ask you to answer the question.
We'll get that question answered outside. Thank you very much all for coming and for being interested. And thank you to the panel. Hi, are you IISD? Yes. Oh, yeah.
My bag there, so that's why I was typing.